Hi, this episode of Crash Course Physics is about collisions. So if you're playing billiards, you've seen lots of collisions, but maybe also other parts of physics, even modern physics, have a lot to do with collisions. Now, collisions come in two flavors, or two extremes and a spectrum in between. They are elastic collisions, or perfectly elastic collisions, and so-called inelastic or perfectly inelastic collisions. Now, this is a whole spectrum, so anything in between can also occur, but we just discussed the two extreme cases here. In an elastic collision, an object coming in at a certain momentum hits a resting object and actually imparts all of its momentum onto the second object. Momentum is conserved, as is kinetic energy. In an inelastic collision, in the same configuration, the two objects actually stick together and share the momentum between them, so they actually travel at the same velocity at the end, if they both have the same mass. So this can be accomplished, for example, by putting some sticky substance in front of the first object. So these two extremes can maybe better be understood if we go into the center of mass system. That is, we look at these two collisions in a moving reference frame that follows the uniform motion of the center of mass. So we just always keep our camera exactly in the middle of the two objects. In an elastic collision, then the two objects now have equal and opposite momenta, half of what the momentum was on the previous slide. And as they encounter each other, they just go back into opposite directions with the same momenta, just in the opposite direction. Again, momentum is conserved, as is kinetic energy, so the kinetic energy at the end is exactly the same as at the beginning. In an inelastic collision, the two objects stick together, so the kinetic energy actually seems to vanish. At the end, the two objects are at rest, but there's no more kinetic energy, so this energy has to be gone somewhere. So this is usually in the form of sound or heat. There's also usually a little bit of sound and heat in a realistic elastic collision, but in an inelastic collision, actually nothing is left for kinetic energy. Now, these inelastic collisions are actually central to particle physics because they allow us to discover new particles such as the Higgs boson most recently. When two particles such as electrons collide, they actually might give off some energy. If the energy or the velocity or momentum of the two particles is not the same as at the beginning, that means that some form of energy has to have been transferred into some other physical manifestation. For billiard balls, this is sound and heat and maybe light if we have, for example, some cannonball. But when we are dealing with particles, these other forms of energy we might understand, and sometimes we don't understand them. Actually, it was a certain missing type of energy that led us to discover a number of now known particles. But the first indication of their existence was a failure to account for all types of energy. So, I hope this little nitpick was enlightening, especially with this link to modern physics. And don't forget to subscribe and follow me on Twitter. See you next time.